Hello children, I hope you're staying safe at home. To continue with the atomic structure and chemical bonding, today we will start from isotopes. Now, it has been noticed that sometimes two or more atoms of the same element will contain the same number of protons, but they have different number of neutrons. So the electrons are arranged in the same way. So they give the atoms same chemical properties, because you know the chemical properties depend on the number of electrons, which is equal to the number of protons. So here isotopes, they have the same number of protons. That means they have the same number of electrons. Okay, so the chemical properties are the same. It is not different. It is only that the number of neutrons are different. Now atoms of the element showing similar chemical properties but possessing different mass is said to represent isotopy, and the varieties of atom are known as isotopes. So when you define isotope, you'll define it as atoms of the same elements having the same atomic number but different mass number. So here you can see examples of isotope. Your first assignment, you'll write down this table. Okay, so there you can see hydrogen has 3 isotopes, carbon has 3, chlorine has 2, oxygen has 2, and potassium has 2. So if you look here, you will see that the atomic number, which is the subscript, okay, is the same in all cases here, but you will see difference in the number of mass number. That is because number of neutrons is more. Okay, so when we come to the structure of isotopes, first let us look at hydrogen. You already saw in the example, hydrogen has 3 isotopes. They are known as protium, deuterium or heavy hydrogen, and tritanium. In your one word answers, if I ask you name heavy hydrogen, you will write down deuterium. Okay, now each have the same atomic number 1, but they have different mass numbers 1, 2 and 3. So when we talk about isotopes, in other words, we are talking about elements which are different only in their number of neutrons. So protium has no neutron, deuterium has 1 neutron, and tritanium has 2 neutrons. Okay, so they are represented as respectively. Okay, now you know, I already told you the subscript which is below denotes the atomic number, and the superscript which is above denotes the mass number. So add this to your assignment. Okay, you will draw the diagram of the isotopes of hydrogen. Now next, moving on to carbon. Carbon atomic number is 6. They have 3 isotopes and their mass number is 12, 13, 14 respectively. Okay, and you are going to draw the structure of isotopes of carbon atoms as well. You'll do this 3 diagrams. Okay, you'll do it in your copies. Okay, so as usual, you know the 3 isotopes are represented by superscript, the subscript is 6, which denotes the atomic number, and the superscript 12, 13 and 14, okay, which denotes the mass number. So it is also written as C12, C13 and C14. Now chlorine. The chlorine has only 2 isotopes, okay, and they have mass number 35 and 37 respectively, and of course the atomic number is the same, that is they have 17. The same number of protons and the same number of electrons. That is why their chemical property is the same. Chemical properties do not differ of all the isotopes of a certain element. And you know, how are they different? They are different because the number of electrons contained in their nuclei is different. It is more or less. So they are represented by Cl subscript 17 denoting the atomic number, and the different superscript 35 and 37 denotes the mass number. Okay, so isotope of this chlorine, you subtract, you know that 35 minus 17 gives 18 neutrons, and this isotope of chlorine gives 37 minus 17, that is 20 neutrons. So what are they different in? They are just different in the number of neutrons. This isotope has 2 neutrons more than this isotope of chlorine. Please draw this structure of isotope of chlorine atoms as well for your assignment. Okay, now moving on to the properties of isotopes. Isotopes have similar chemical properties. Like I already told you. Why? Because they have the same number of electrons. And why are they showing the same chemical properties? Because when we talk about chemical properties, we are talking about how the valence electrons, either they are lost or gained in a chemical reaction. So since they have the same number of electrons, they have the same chemical properties. Okay, and they will have the same electronic configuration as well. Okay, and the chemical properties, you know, it is determined by the electronic configuration of an element. So isotopes of an element are chemically alike, they are the same. Okay, now the chlorine atom of mass 37 undergoes the same reaction as the chlorine atom of mass 35. So they have the same chemical properties. Now next property is isotopes differ in few physical properties such as density, boiling point, and so on. Now these physical constants, that is, they do not change, or physical properties depend on the atomic mass. Okay, the mass number. That means the physical properties will be different for different isotopes. Okay, so isotopes, they have different mass numbers due to different number of neutrons. So therefore the physical properties will be different. For example, the boiling point of protium is 20.38 Kelvin, and that of deuterium is 23.5 Kelvin. So remember children, the higher the mass of the isotope of an element, the higher is the boiling point. Okay, now isotopes like tritanium, carbon 14 illustrates another difference in physical properties that occurs between isotopes, which is known as radioactive. That means they are radioactive. Now when we talk about radioactivity, you know that there are extra neutrons in the nuclei. So what happens? It causes them to become unstable. Okay, they are unstable because of the extra there are extra neutrons in the nuclei, so they become unstable. So what happens? The nuclei continuously break up. Okay, and when they are breaking up, what they do is they emit certain types of radiation. So carbon 14 and tritanium are known as radioisotopes. Okay, the spontaneous, what is radioactivity? Definition of radioactivity is the spontaneous decay of unstable radioisotopes is known as radioactivity. So when we talk about decay, we are talking about how the nuclei, the nucleus of these element or atom is continuously breaking up, and they are emitting certain radiation. Now what are the uses of isotopes? Another assignment for today, you'll write down. First is isotope of cobalt is used in radiotherapy for treating cancer and other diseases. Okay. Carbon 14 is used for determining the age of historical and geological material. Now, how many millions of years ago a fossil is found? So, it is used for determining the age of such fossils. Okay. Now, an isotope of uranium is used as a fuel in nuclear reactors. An isotope of iodine is used in the treatment of goiter. Radioactive isotopes are used in industry to detect the leakage in underground oil pipelines, gas pipelines and water pipes. You know that oil pipelines, gas pipelines are deep inside the earth. So radioactive isotopes are used to find out if there is a leakage in these underground water pipes. Okay. Now we move on to isobars. Now when we talk about isobars, it is just the opposite of isotopes. Now remember, in isotopes the atomic number was same, the mass number was different. So what is opposite in isobars? The mass number is same but the atomic number is different. So if the atomic number is different, what will happen to the chemical properties? It will differ, because the number of electrons in the outermost shell will be different in isobars, right? So they are atoms of different elements with the same mass number but different atomic numbers. So since the properties, you know, it depends upon the atomic number, the electronic configuration, so they have both different physical as well as chemical properties. Examples of isobars: argon and calcium. Here you can see, okay, these are isobars. They have the same, you can see 40 40 54 54. That means they have the same number of mass number, sorry, they have the same mass number, and here the subscript means the atomic number. So you can see they have different atomic number. Okay, so we will stop here, children. I've already given you the assignment. So till we meet again, stay safe. God bless you.